वीडियो में हम सॉल्यूशन ऑफ डिफरेंशियल इक्वेशन यूजिंग लैपलास ट्रांसफॉर्म डिस्कस करेंगे। आपको वीडियो पसंद आएगा, आप लाइक करिए, शेयर करिए, चैनल को सब्सक्राइब करिए। डू नॉट फॉरगेट टू प्रेस द बेल आइकन। जब हम सॉल्यूशन ऑफ डिफरेंशियल इक्वेशन की बात करते हैं तो हमें सिस्टम का रिस्पॉन्स निकालना होता है। एंड व्हेन वी आर टॉकिंग अबाउट द रिस्पॉन्स, तो रिस्पॉन्स एक्सपीरियंस हम दो कंपोनेंट में करते हैं। तो टोटल रिस्पॉन्स ऑफ ए सिस्टम is equal to natural response and another is forced response. Now, natural response of a system is due to the initial conditions. That is because of initial conditions, and the forced response is due to the input to the system. The total response of the system is equal to the forced response when the initial conditions are equal to 0. So if initial conditions are 0, then we can write the total response is equal to the forced response. That's how we can define. Now for that, let us consider a LTI system having input X and having output Y. That is input, and we are having Y as output, and both are function of time. Fine. So that is the equation which describes the system. The nth derivative, time derivative of Y plus n minus 1th derivative with respective coefficients of Y plus a naught y t is equal to bm mth derivative of x and plus with m minus 1th derivative with some coefficients of x and addition with so on, we are having b naught xt. That is the equation which describes the system with the differential equation. Now, the above equation, the equation number 1 we are having, this equation can be solved by the time differential property of Laplace transform, which replaces this term by s raised to the power n by s. First term, this term is replaced with this, and this term is replaced with, here we are talking only about the differential term, so only this term, and this differential term is replaced with s raised to the power n minus 1 y, capital Y, s. So, etc. all the differentials can be replaced in the same fashion by assuming that initial conditions of the variables xt and yt are 0. Okay? So, because we want to have the total response by assuming the initial conditions are 0, तो उसके रिस्पेक्ट में xt और yt की जो इनिशियल वैल्यूज हैं वो 0 हो जाएंगी। अगर हम फर्स्ट डेरिवेटिव की बात करते हैं तो हमारे पास टर्म आएगी y 0 नेगेटिव। सेकेंड डेरिवेटिव की बात करते हैं तो हमारे पास टर्म आएगी y 0 और नेगेटिव डेरिवेटिव विद रिस्पेक्ट टू टाइम एंड सो ऑन, वी आर हैविंग द टर्म। और जब हम nth डेरिवेटिव करेंगे तो हमारे पास आएगा nth डेरिवेटिव ऑफ n minus 1th derivative of y 0 negative. So that is equal to 0 because we are assuming initial conditions are 0. जब हम x के रिस्पेक्ट में बात करेंगे फर्स्ट डेरिवेटिव, तो वी आर हैविंग x 0 minus 2 and derivative of x 0 negative सेकेंड डेरिवेटिव का एनालिसिस करेंगे तब आएगा एंड सो ऑन एंड आफ्टर दैट जब लास्ट हमारे पास nth डेरिवेटिव बचेगा तो जब उसका हम एनालिसिस करेंगे तो हमारे पास n माइनस 1th डेरिवेटिव ऑफ x 0 नेगेटिव. So these all values are become 0 because initial conditions हम 0 लेके चल रहे हैं. Now we can apply the Laplace transform on this equation number 1. So after applying the Laplace transform on equation 1. So what is equation 1? So equation is having power an, coefficient an and differential power n. We can write it a capital N s raised to the power n ys plus a n minus 1 s raised to the power n minus 1 ys plus so on a naught ys. So that is on this side we completed the Laplace transform. Now on the other side we are start computing that Bm, the coefficient, the differential is mth differential, so s raised to the power m xs plus Bm minus 1 s raised to the power m minus 1 and xx is the variable in Laplace. And plus last is x naught xs in the s domain. Now we can take y as common on this side and we can write an s raised to the power n plus an minus 1 s raised to the power n minus 1 plus so on a naught. And on the other side we can write xs, we can take common and we can write bm s raised to the power m plus bm minus 1 s raised to the power m minus 1 and so on. At the end we are having b naught. Now we can also write this equation in the rational polynomial, that is ys divided by xs in the rational polynomial, that will be an sn is starting with the bm sm plus bm minus 1 s raised to the power m minus 1 so on b naught, and this term will be the denominator. This will be an s raised to the power n plus an minus 1 s raised to the power n minus 1 plus so on. That's how we can represent this number. Now we can find out the Laplace transform of the given differential equation in this form. Here we are having this representation as the transfer function. You can call it transfer function of the system, and the system is defined by Hs. System is defined by Hs, and that is the transfer function of the system, and that is the ratio of output over input keeping initial conditions 0. So we can also define the output over input keeping initial conditions, you can represent with IC, that is equal to 0. So, and we can also write it like the Laplace transform of 0 state response, Laplace transform of 0 state response divided by Laplace transform of input. So that is another way to define it. So this is the definition of transfer function. So we can find out the Laplace transform of 0 state response, or we can say the forced response, which is the product of this HS and XS. We can also represent the YS can be determined, which is the product of input and the HS, the transfer function. And we can also find out YT, which is the Laplace inverse of YS. YT is the time domain response of a system, and that is the Laplace inverse of XS into HS. That's how we can do it. Now, for further understanding, we can also determine the impulse response also, right? So this YT is known as ZSR. So this means zero state response. So that's how we can define it. Now, to determine the impulse response, so we can say that if the input to a system is impulse, unit impulse, that is delta t, right? So it means then we can have the Laplace transform of this is 1. And if it is 1, then equation number 2 can be written as the Ys is equal to 1 into Hs, and that is equal to Hs. Now we can have Yt here, which is the Laplace transform of Ys, and that is equal to the Laplace transform of Hs. This is nothing but, we can say, this is Ht, and Ht is what? That is impulse response of the system. So that's how we can define the impulse response of a system. So hope you understand the solution of the differential equation, impulse response, zero state response, and the transfer function. So hope you like the video. Please subscribe the channel so that we can provide the better video